Hi everyone. So in today's session we are going to see a problem on Cohen Sutherland line clipping. If you are clear with the theory behind Cohen Sutherland, you can directly move to the problem, the numerical problem. The time will be given in the description. Okay. So before going on to the problem, I'll just give a brief idea. I'm not going to explain about the Cohen Sutherland algorithm. I'm just giving an idea on how to solve a problem. Okay. You need to know two things. One is you need to know how to assign region code, and second you have to know how to find the intersection point. Once you know these two things, you can easily do the line clipping problem. Okay, so we will do a numerical problem which was asked for the previous year university question. So before that we will have an idea about it. So this is the window area which we are interested in, where this point will be x min, y min, and this will be x max and y max. So this is the left boundary. I can say this vertical line is the left boundary and the value will be x min, and this will be the right boundary with x value as x max, and this is the bottom boundary with y min, and this is the top boundary with y max. So everything inside this region is our area of interest, where this the line coming into this part will be accepted and anything other than the window will be clipped away. Okay, so while assigning region code, it is a 4-bit code, and bit 4 will be representing whether the point is outside or above the top window. Okay, above the top margin, and B stands for bottom, which means whether the point is below the bottom boundary, and R stands for right boundary. Suppose if the point is outside the right boundary, R bit will be set, and suppose if the point is to the left of the boundary, that bit will be set. Okay, so suppose if you are having a point over here, it is to the left of this left boundary, or in another way you can say the x value is less than x min. Suppose if x value is less than x min, the left bit will be set. Okay, it is not less than right boundary, so that will be 0. It is not less than bottom boundary, that will be 0. It is not greater than top, so that will also be 0. Okay, and now suppose if we take a point over here, it is not less than x min, so left boundary will be 0 only. When you check with the right boundary, it is a value which is greater than the right boundary, so right boundary, that will be set as 1. And bottom, it is not less than bottom and it is not greater than top, so those bit will be 0. So if you check this part, it is above the top boundary, so 1 0 0 0, and this part it is below the bottom line, so it will be 0 1 0 0. And now if you check this part, it is below the boundary, below the lower boundary and to the left of left boundary, or less than left boundary, so the bit left and below will be set and remaining will be 0. Okay, similarly you can assign for all the 9 regions. So here it will be not top, bottom will be 1, right will be 1, left will be 0. Here in this case, top will be 1, bottom will be 0, right will be 1, left will be 0. In this case again, top will be 1, bottom will be 0, right will be 0, left will be 1. So these are the different region codes. So you should be knowing how to assign a region code, and to the formula for that is, we can just say if x less than x min, you can set the left bit, or if x is greater than x max, you can set the right bit, and so on. But the actual definition will be, we will be finding for the left boundary, we will be finding x minus x min, and the sign bit will be given to the bit position. So if x minus x min is giving a negative value, sign bit will be set, that 1 will be given to this bit. So, okay, and similarly the other values. If it is for the checking the right bit, it will be sign bit of x max minus x, and so on. Whenever the result is negative, you will get a sign bit as 1. Okay, so that is the actual working behind. Okay, now we will come to the intersection point, how we are going to find the intersection point. For that we will have a example. So suppose if you are having a point over here, say P1, and this is P2. So P2 is having a region code 0000 and P1 is having a region code 1001. Okay, as both the points are not 0000, we can say the line is not completely inside, and when we do an AND operation, the result will be 0000. Okay, if the region codes are ANDed and if you are getting 000, the meaning is that there may be a portion which is inside the window and we have to find the intersection point. So now the question is how to find the intersection point. We will take one point, so we are taking P1. First we will check with the left boundary. Okay, here you can see P1 is to the left of left boundary, which means of course this line is going to make an intersection with this point. So first we will find the intersection point P1 dash. Okay, now we will assign the region code for this point. This point of time the region code will be 1000. Again if you do an AND operation you will get 0000. So there is one more. Again we will have to find an intersection point. Now with this point, if you check with the left boundary, it is not less than left boundary, so that is fine. Next we will check with the right boundary, it is not greater than right. Next we will check with the bottom, it is not less than bottom, and when we check with the top boundary, it is greater than the top boundary, which means it will have an intersection point with the top boundary. So we will find out that. So that will be P1. I am calling it as P1 double dash. Now if you find the region code of P1 double dash, it will be 0000. So now both the points is having 0000, which means both these points are inside the window. We will save this section. Okay, now we need to find how we are going to find this intersection point. For that we are going to use the slope intercept equation. Okay, so we know the point, I am calling it as x1 y1. So this is the point x1 y1 and we are interested in finding the intersection with this point, so I am calling it as xy. But as you know, this is the left boundary, so the x value will be x min, which means this value is known. So we have to find out this y value. The formula for that is y is equal to y1 plus m into x minus x1, where m is equal to y2 minus y1 by x2 minus x1. We are having 2 points, this is x2, y2. So from these 2 points you can find out the slope. So m is known, y1 is already known, this is y1, we are already having that. x1 we already have that, that is this point, and x will be, in this case it will be x min. Okay, suppose if we are finding an intersection with right boundary, this x value will be replaced with x max. Okay, while doing the problem it will be much more clear for you. And similarly, now suppose if we are going to find an intersection point with this horizontal boundary, that is either top or left, you will see that. So again we are going to use the slope intercept equation. So once we are having an intersection over here, I am calling this point as xy, and here we know y value is y max, that will be y max. So the value to be found is x. So you know x1 y1, xn is known, y1 is known, here y value is known, this x is unknown. So the equation will be x is equal to x1 plus y minus y1 divided by m. So as I have said earlier, m is known, x1 is already known, y1 is known. Now this y will be the boundary, that is in this case it will be y max. Suppose if we are finding the intersection with point with bottom boundary, it will be y min. Okay, again as I have said, while doing the problem it will be much more clear for you. Okay, hoping that this much is clear, we will go to the problem. Okay, so let's start with the problem. So this was a university question. The window points are given, the window coordinates are given, and the points P1 and or P and Q are given. We have to find the portion of the line which is lying inside the window region. Okay, so the first point is minus 20, minus 20, and you can see again. So this is x min and y min. So x min is 20, minus 20, y min is minus 20, and x max is, you can see this is 40, and y max is 30. So that is 2 points. So the next point is 40 minus 20. So this is A, B is 40 minus 20. So what you can do is that, it is 20 to 40. So you can just give a unit like say minus 10, 0, 10, 20, 30, 40. So this will be the point 40 minus 20. This is point B. Okay. Now if you find C, it is 40, 30. So the x coordinate will be 40 itself and y is 30. So from minus 20, you can say, you can take the 10 units. So minus 10, 0, 10, 20, 30. So this is the point 40, 30. And next one is minus 20, 30. So this is the point minus 20 and this is the point 30. So that is minus 20, 30. Minus 20, 30. So this is the window area. Okay. So roughly I have given a reasonable unit size. Okay. Now the points. One is minus 30, 20. So x is minus 30. So it will be again 10 units to the left and it is 20. Or from here you can say 30, 20. So at and around here you will be having the point P minus 30, 20. And what is the point Q? It is 60, 10. So 40, 50, 60 and it is minus 10. So minus 20, minus 10. So around here you will be having the point 60 minus 10. Okay. So once you know that, you can draw the line from P to Q. Again, you will be having a rough idea of where the intersection points will be. Okay. This will help you. Okay. Now we are going to find the region chords. Now for region chord, you know how to find the region chords. So it will be like, suppose if you have to find the region chords of P, bit 4, bit 3, bit 2, bit 1. So top, bottom, right, left. So if you see this point, we will be doing y max minus y. It will be like, that will be the equations to do that. But and you can get the correct region chord. But from looking at this figure itself, you know what is happening. It is just to the left of the left boundary. It is not below and it is not above. So the point you can directly assign it as, so top will be 0, bottom will be 0, right will be 0 and left will be 1. So the point P is 0, 0, 0, 1. And what about Q? In the case of Q, it is to the right of the window. It is not below and it is not above. So it should be top is 0, bottom is 0, right is 1 and left is 0. So this is the advantage of drawing a reasonable figure. Okay. But of course you have to calculate, but you can cross check with this. We are having these 2 points. Now what we are going to do? Now we will do an AND operation and the result is a 0 value. So here you can see this is a point P and for Q it is 0, 0, 1, 0. If you do an AND operation, 1 and 0, 0 and 1, 0, 0, which means you will have to find the intersection point. Now we are starting with P. Once you start with P, you know that it is to the left of left boundary, which means we have to find an intersection point with the left boundary. I am calling it as say P1. Okay. And what will be the point? I am calling this as X and Y, where X will be X min. Okay. So one point is X min and we have to calculate Y. If you have to calculate Y, we will be using slope intercept equation, which means we have to find out M. So we will write the informations we are having. So this is X min, Y min, X max and Y max. What is X1, X2, X1, Y1? That is minus 30, 20. So minus 30, 20 and X2, Y2 is 60 minus 10. 60 minus 10. So slope will be Y2 minus Y1 by X2 minus X1. That is minus 10 minus 20. So that will be minus 30 divided by X2 minus X1. 60 minus 30 So 60 minus minus 30, that is minus 30 by 90, which is 1 by 3, minus 1 by 3. So the slope is minus 1 by 3. Now you have to find out the y position. Okay, so you are already aware with the equation. Now with this information we are going to calculate y, the y value, that is equal to y1 plus m into x minus x1. y1 is, this is the point, so y1 is, this is x1 y1, that is 20 plus m into, that is minus 1 by 3, so it is minus 1 by 3 into x minus x1, where x is the intersection point, that is x min. X min is minus 20 minus the point x1. So here you can see x1 is minus 30, so minus 30, so that will be 20, this will be minus 20 plus 30, that is plus 10, that is minus 10 by 3. Okay, I am approximating this as 3, so that will be 20 minus 3, the point is 17. So this point turns out to be minus 20, 17, and if you find the region code will be 0, 0, 0, 0, which means this point is inside. Okay, so what we can ignore, the line from P to P1 can be ignored, so that much is fine, right? Now what we'll do, we have to find this intersection point. So we are going to start from Q, so this will act as x1 and y1, and for the slope of the line is not going to change, so m will be still minus 1 by 3, and now we have to find this point. So what will be the xy position? Again, this is the vertical line, so x value is x max and y value is unknown. We are going to calculate this y value. Okay, again we are going to use the same equation, but the values are going to change, so we will find it out. So we will see how we can do that. Again, how we are coming up with this intersection point? First, with the region code we will check whether this point is to the left of left boundary. Now then we will check whether it is to the right. Now you can see it is to the right, which means there is an intersection point with the right boundary. That's why we are going to check the point from here. Okay, so now what we are going to do, we are going to find the y value with the same equation, where y1 is minus 10, so that is minus 10, plus m is minus 1 by 3, so minus 1 by 3. X value will be x max, that is, here you can see x max is 40, minus x1 is 60, that is minus 10. Here you can see 40 minus 60 is minus 20, so this value will become positive 20 by 3, so this will become 6.66 something, so I can approximate it to 7, so this will be minus 10 plus 7, that is approximately it is minus 3. Okay, so what will be this point? This point will be 40 comma minus 3. Again, if you check, I am calling this point as q dash. If you find the region code of q dash, it will be 0, 0, 0, 0, which means now this portion of the line is discarded from q dash to q, and we can save the values p1 to q1, because both the region codes are now 0, 0, 0, 0, which means the line is entirely inside. So this much portion of the line will be saved, minus 20, 17 to 40 minus 3. So this is how we will calculate a numerical problem on Cohen Sutherland. Okay, I hope it is clear for you. Thank you.